This is a key to test 1, and in problem number 1, you're given this rational equation, and you're asked to solve the following rational equation, show all work, and then you need to clear the fractions at the beginning of the problem, so don't use any other method. So I'm telling you what method to use in this particular problem. So the first thing you have to do is to find the least common denominator. Now to find the least common denominator of these rational expressions, you have to make sure that all of the denominators are in factored form. So this is already in factored form. This is in factored form. There's nothing else you can do to these two expressions in terms of factoring, but you can factor this one. And when I factor this, you'll notice that the factors of this trinomial are these factors here. So if you factor this, you should get x minus 9 times x minus 4. And you can check yourself by FOILing this out, multiplying these two binomials, and you'll get this trinomial. So notice that these two factors here are these factors here. So the least common denominator, remember, has to include every factor that you see. And it's a product of those factors. So don't put these factors with a comma between them. Sometimes there's some students that do that. That's not stating the least common denominator. All you're doing is stating the factors of the least common denominator. So when stating the least common denominator, it is a product of these factors. So the first factor I see is x minus 9. So that has to be a part of the least common denominator. And the next factor I see is x minus 4, and there's only one factor that I see here, so I must use it. Then the next factor I see is x minus 9. I already have it. Don't list it again because you no longer have the least. You have a common denominator. So if you don't use the least, it's going to make things so much more difficult for you when you solve this equation. So always use the least common denominator. And the next factor I see is x minus 4, which I already have. So the least common denominator is the product of x minus 9 and x minus 4. Now the next thing you want to do is find the restrictions of your variables. Now remember, you can never divide by 0. So if you look at this expression that's in the denominator here, x minus 9, and you can look at this and determine what the value of x is that will make this expression equal 0. So 9, right? So 9 minus 9 is 0. So if you add 9 to both sides, when you solve this linear equation, you get x to be 9. So that is a restriction. So x cannot equal 9. And for this one, the same thing. Do the same thing. When x is 4, that denominator is 0. So x cannot be 4 as well. Over here, x minus 9. Well, when x minus 9, we already dealt with that. That's that expression here, x minus 9 is 0 when x is 9, and then over here we've already dealt with that here. So when x is 4, 4 minus 4 is 0, and this denominator becomes 0. So those are your two restrictions. Then we're going to solve this, and we're going to indicate the proposed solution. So remember, when you get a solution here, you have to check because it may not be a solution to the original equation. So you always have to check. And basically you're looking at these restrictions here. Okay, so let's go ahead and solve this by clearing the fractions. So when you clear the fractions, basically you're taking this least common denominator and you're going to multiply both sides by that least common denominator. So you're going to say the least common denominator times the left side. So it'll look like this, x minus 9 times x minus 4 times the left side, which is the sum of these two fractions, these two rational expressions. So 5 divided by x minus 9 plus 11 divided by x minus 4 equal, and then do the same thing on this side. So what you do to one side, you do to the other. X minus 9 times x minus 4 times this rational expression. Now when you rewrite this rational expression, use the factored form. So I'm going to write this as 9 times x minus 9 times x minus 4. Okay, so that's the first thing you have to do. Then you'll notice that these two rational expressions are being multiplied by this least common denominator. So you're going to distribute. So you can distribute the least common denominator through here. So basically you're multiplying each of those rational expressions by the least common denominator. So I'm going to rewrite this as x minus 9 times x minus 4 times that first rational expression plus, and then the LCD times that second rational expression, x minus 9, x minus 4 times 11 divided by x minus 4 equal, and I'm going to go ahead and reduce these. So these two factors here reduce with these two factors here, and you get a factor of 1. So remember, the whole purpose of clearing the fractions is to get these denominators to be factors of 1. So you want this to be a factor of 1, you want this to be a factor of 1, and you want this to be a factor of 1. So that's where you see that 1. So over here you just get 1 times 9, which is 9. And then we're going to go ahead and reduce here. So notice these x minus 9's divide out. So x minus 9 divided into itself is 1. So hence a factor of 1. Same thing here. Over here the x minus 4's divide out. And so basically you have 1 times x minus 4 times 5, which is 5 times x minus 4, plus, and then 11 times x minus 9 equal 9. And so notice I went from a rational equation to a linear equation. So that's why you have to check your proposed solution. So distributing, getting rid of the parentheses, I'm going to get 5x minus 20 plus 11x minus 99 equal 9. Combining like terms, I get 5x and 11x is 16x. A negative 20 and a negative 99 is a negative 119 equals 9. So I'm solving this linear equation. I'm going to go ahead and add 119 to both sides. What you do to one side, you do to the other. So I get 16x, this is 0, equal 9 and 119 is 128. And then finally, dividing both sides by 16, I get my proposed solution to be 128 divided by 16 is 8. All right, so that's my proposed solution. So that is a solution to this linear equation, but it may not be a solution to the rational equation. All right, so your proposed solution is is 8. All right, so the way to do that is to check your restrictions. So is 8 one of these restrictions? The answer is no. So if I did all this work correct, then this is going to be a solution since it's not a restriction. Okay? All right. So that's it. So your solution is, so this is going to be our solution since it is not a restriction. Okay? All right. So that was number 1. All right. Let's look at number 2. Okay, so in number 2, you want to divide the following complex number. Now I'm going to go ahead and rewrite this. This is 2 plus 5i divided by 3 minus 2i. So 2 plus 5i divided by 3 minus 2i. Okay, so remember, when you're dividing complex numbers, you don't want an I in the denominator. So we're going to have to get this denominator to be a rational number. And since this is a binomial, since this is a complex number, one way to get this to be a rational number is to multiply both numerator and denominator by the conjugate of the denominator. So the conjugate of 3 minus 2i is 3 plus 2i. But what you do to the numerator, you have to do to the denominator. All right, so the conjugate. So remember the word conjugate. All right, so the conjugate of 3 minus 2i is 3 plus 2i. And what that does, remember, is that when you multiply these two conjugates, you're going to get a rational number. And you're going to see that. All right, so let's go ahead and multiply the numerators and then multiply the denominators. So basically, I'm going to go ahead and put that here. So basically, you have 2 plus 5i times 3 plus 2i divided by 3 minus 2i times 3 plus 2i. All right, so when I multiply the numerators using the idea of FOIL, I get 2 times 3 is 6. So I get 6 plus the outer 2 times 2i is 4i, and then the inner 5i times 3 is 15i, and then the last, a positive 5i times a positive 2i is a positive 10i squared. Okay, so the I squared is important. Divided by, and then we do the same thing with the denominator. So when I multiply that out, I'm going to get 3 times 3 is 9. The outer, so remember these are conjugates, right? So since those are conjugates, the outer and the inner will add up to be 0, and you're going to see that. The outer, 3 times 2i is 6i. The inner, negative 2i times 3 is a negative 6i. So notice this right here adds up to be 0. And then a negative 2i times a positive 2i is a negative 4i squared. Now remember that I squared. So one of the things you got to remember is that I squared is defined to be a negative 1. So combining like terms and replacing I squared with negative 1, I get 6, 4i, and 15i is 19i plus 10 times a negative 1. I squared, remember, is negative 1. Divided by 9, this is 0, minus, that's a 9, minus 4 times negative 1. Alright, so what we get at this point is 6 plus 19i. Alright, 10 times a negative 1 is a negative 10, divided by 9. A negative 4 times a negative 1 is a positive 4. 6 subtract 10 is a negative 4, so I get negative 4 plus 19i divided by 9 plus 4 is 13. And remember, they wanted you to write it in the form a plus bi, so I'm going to write this as negative 4 thirteenths plus 19 thirteenths I. Alright, and so that is number 2. Okay, number 3, they wanted you to simplify this expression here. So let me go ahead and rewrite this better. So that says 5 times the square root of a negative 8 minus 4 times the square root of a negative 18. Alright, so you got to remember that the square root of a negative 1 is defined to be I. And so when I look at this, I can rewrite this as 5 times the square root of a negative 1 times the square root of 8 minus 4, same thing here, square root of a negative 1, square root of 18. So remember we just said square root of a negative 1 is defined to be I. So I can rewrite this as 5i square root of 8 minus 4i square root of 18. Alright, now remember you have to rationalize or simplify your radicals. So the square root of 8, remember the largest perfect square that goes into 8 is 4, so the square root of 8 is the square root of 4 times the square root of 2, so that's 2 square root of 2. So this becomes 5i times 2 square root of 2. Square root of 8 is 2 square root of 2. Minus 4i times, and then the same thing with the square root of 18. So the square root of 18 is the square root of 9 times the square root of 2. And the square root of 9 is 3, so you get 3 square root of 2. So that becomes 3 square root of 2. Simplifying this further, 5 times 2 is 10, so I get 10i square root of 2, minus, and then 4 times 3 is 12, 12i square root of 2. These are like terms, so I can combine them. 10i square root of 2, subtract 12i square root of 2 is negative 2i square root of 2. Alright, so that was number 3. Alright, number 4, let's look at number 4. So number 4, we have this, number 4. So you want to solve this quadratic equation, but the direction says, and you have to follow directions, the direction says using a square root property. So when I'm going to go ahead and write this better. So I get 3x minus 5 squared equals 45. So using a square root property, remember you're trying to isolate this variable x here. So this expression here is being squared. So the opposite of squaring is to take the square root of both sides. But remember, you get that plus or minus. So the square and the square root undo each other. So you have this linear expression here, 3x minus 5 equals plus or minus the square root of 45. And I can simplify the square root of 45 because the square root of 45 is the square root of 9 times the square root of 5, and the square root of 9 is 3, so you get 3 square root of 5. So I'm going to put that here. So I get 3x minus 5 equals plus or minus 3 square root of 5. And then this is an easy one to deal with. Since this is an irrational number, I'm just going to go ahead and add 5 to both sides. Now be careful, some of you have a habit of saying this is 8 and that's not the case. So you got to be careful. Those are not like terms. So I get 3x, this is 0, equal 5 plus or minus 3 square root of 5. And then divide both sides by 3. You get 3 divided by 3 is 1, so you get x to be 5 plus or minus 3 square root of 5 divided by 3. You can leave your answer like this. Or if you, and let me go ahead and do that here. Let's see. Or if you did this, you could say, well, let me go ahead and write it here. This right here, recall, is you can rewrite this as 5 plus or minus 3 square root of 5 divided by 3. Remember, I can write this as two separate fractions, so that's 5/3 plus or minus 3 square root of 5 divided by 3. And then the 3's divide out, so this becomes 5/3 plus or minus square root of 5. All right, so 5/3 plus or minus square root of 5. Okay, so that was number 4. All right, number 5, you want to solve this quadratic equation using the quadratic formula. So you have 4x squared. Now remember, you got to put it in descending order and in standard form. So I got to subtract this 3x from both sides, and then plus 2 equals 0. So since I'm using a quadratic formula, remember a is going to be 4 here. B will be the coefficient of x, so that's -3, and c is your constant, which is 2. And so substituting into the formula, I get x equals the opposite of b, the opposite of -3 is a +3, plus or minus the square root of b, which is -3 squared, minus 4. Remember, the quadratic formula is the opposite of b, plus or minus the square root of b squared, minus 4ac, all divided by 2a, so make sure the whole thing's being divided by 2a. Minus 4a, a is 4, and then c is 2. All of that, so you got to extend this. Don't just say this is being divided by, is this whole thing. So I'm looking for this division symbol being extended. All divided by 2 times a, which is 4. Okay, so I get 3 plus or minus the square root of -3 times itself is 9. A -4 times a +4 times 2 is a -32, divided by 2 times 4 is 8, equal 3 plus or minus the square root of 9 minus 32 is a -23, divided by 8. And just as before, you got to remember that the square root of a -1 is defined to be I. So I can rewrite this as 3 plus or minus I square root of 23 divided by 8. And so that's the answer you had to give me. So you cannot leave it like this, because you all know that the square root of a -1 is defined to be I. All right. So that is number 5. Okay, now let's look at number 6. All right, number 6. So number 6, you're solving this radical equation, and I did tell you that you had to show that you checked for extraneous solutions. So some of you have a habit of looking at the solutions and then just looking at this and seeing if it works. I needed you to actually show it. All right, so it was 2 points actually verify that you did check this. Okay, so let me go ahead and rewrite this over. So I get the square root of 5x minus 9 equal x minus 1. Okay, so notice that the radical, the square root's already by itself, so that makes things a lot easier. So to get rid of that square root symbol, since I'm square rooting, the opposite is to square, so I'm going to square both sides. And when I square both sides, the square and the square root undo each other, so you're left with the radicand, 5x minus 9. And when I square this binomial, I'm going to get x squared minus 2x plus 1. All right, so notice I went from a square root equation to a quadratic equation. All right, so remember, when you raise both sides to an even power, sometimes you do involve extraneous solutions, so you got to check. Okay, so I'm going to bring all the terms to the side since x squared appears on the right. And when I do that, I'm going to go ahead and subtract 5x on both sides. And so I get -9 equals x squared, and -2x and a -5x is a -7x plus 1. Adding 9 to both sides, and notice I'm aligning my like terms. -9 plus 9 is 0, equal x squared minus 7x plus 10. And I'm going to go ahead and transpose both sides to get 0 on the other side. So I get x squared minus 7x plus 10 equal 0. Okay, so this is factorable. So I have this quadratic equation. I'm going to go ahead and factor it. It is factorable. And when I factor this, I get x minus 5 times x minus 2 is equal to 0. And then setting each factor equal to 0 using the zero factor property, I get x minus 5 equals 0, x minus 2 equals 0. And I want you to notice I went from a square root equation to a quadratic equation to two linear equations. So x equals 5, x equals 2. Now remember, these are your proposed solutions. They may or may not be solutions to the original equation, so you have to check, because some of these or all of these may be extraneous. Alright, so let's check x equals 5. So always go back to the original. You must substitute into the original. So remember, these solutions are solutions to this quadratic. That is a true statement, but they may or may not be solutions to the radical because we squared both sides. We raised both sides to an even power. Alright, so here's the original. So the original is the square root of 5x minus 9 equal x minus 1. So in place of x, I'm going to substitute 5. So you have the square root of 5 times 5 minus 9, and I want to see if that's going to equal 5 minus 1. 5 times 5 is 25, and so I get 25, the square root of 25 minus 9, and I want to see if that's going to equal 4. Well, 25 minus 9 is 16, right? So it becomes the square root of 16, and the square root of 16 is 4, and 4 does equal 4. So this is a solution. So this proposed solution is actually a solution to the original equation. Now we're going to check x equal 2. Do the same thing. So I get the square root of 5x minus 9 equal x minus 1. Go back to the original equation. So in place of x, I'm going to substitute 2. So I get the square root of 5 times 2 minus 9, and I want to see if that's going to equal 2 minus 1. Well, 5 times 2 is 10, so I get a square root of 10 minus 9. 10 minus 9 is 1, so that's the square root of 1, and the square root of 1 is 1. 2 minus 1 is 1, and those are equal. So both of these proposed solutions are solutions to the original. So none of these are extraneous. So these are the solutions. Okay? Alright, so that was number 6. So in number 7, we have the absolute value equation. And this is an easy one because the absolute value expression is already by itself. Remember, the best way to solve this absolute value equation is to actually write it as two separate equations without the absolute value bars. So I get 4x minus 3 is equal to 7, and then 4x minus 3 equals a negative 7. Alright, so remember the idea of that absolute value is that those are opposite sides of 0 in the number line. So that's why you see a positive 7 and a negative 7. So adding 3 to both sides, I get 4x equal 10. Dividing both sides by 4, I get x to be 10 fourths. Reduced is 5 halves. So there's one of your solutions. Over here, adding 3 to both sides, I get 4x equal a negative 4. Dividing both sides by 4, the other solution is negative 1. Alright, so those are your two solutions. Okay, so in number 8, that's another easy one. You just wanted to find the distance between these 2 points and also the midpoint. And I did give you the formulas for those. So let me go ahead and rewrite this over. So the first point is negative 9, 3, and the second point is negative 2, 7. And remember, sometimes it helps if you label these. So let's call this the first point. So it'll be x1, y1, and this will be x2, y2. And so let's do part A. So part A is where you find the distance. So I'm going to use the distance formula. So I get the square root of, remember you subtract your x coordinates. So I'm going to go ahead and just use the same thing we had, your x2 first. So that will be negative 2, subtract a negative 9. Negative 2, subtract negative 9, and I square that. Plus, and then you subtract your y coordinates. 7, subtract 3, squared. So that's going to equal the square root of, alright, so that expression here becomes negative 2 plus 9 squared, and then 7 minus 3 is 4, so that's 4 squared. So that becomes the square root of negative 2 plus 9 is 7, right? So I got 7 squared plus 4 squared. Well, 7 squared is 49. 4 squared is 16. Okay? And then 49 plus 16 gives us 65. So you have the square root of 65. And there's no perfect square other than 1 that goes into 65, so this is your answer. So that's your distance. So there's the work, there's the distance. Part B, there's really no work to do in Part B other than to simplify the fractions. But remember, you're finding the midpoint, so you must use parentheses. The midpoint is a point. And to find the midpoint, you're going to add your x coordinates together. So you can say negative 9 plus negative 2, and you take half of that, comma, and then 3 plus 7 divided by 2. So you had to show that. And so you get negative 9 plus 2 is a negative 11, so you get negative 11 halves. 7 plus 3 is 10. 10 divided by 2 is 5. And so there's your midpoint. All right, so that was number 8. In number 9, that was an easy one as well. So you're given the circle, and you want to find the center and radius. So remember, the standard form is x minus h squared plus y minus k squared equals r squared. And so if you look at this, if I rewrite this right under here, this becomes x minus 5 squared plus, and then right here, this y plus 3 becomes y minus a negative 3 squared. Remember, y minus negative 3 is the same thing as y plus 3 equal, and then 18. Okay, so here's your h. So h is 5, so the center is hk. Remember, the center is hk, right? So the center is 5, comma, and then k is this negative 3. So there's the center. The radius, to find the radius, see this r squared is equal to 18, right? So r squared is equal to 18. To solve for r, you're going to take the square root of both sides, but don't do that plus or minus this time because the radius is distance, so that's positive. So you get r to be the square root of 18, and the square root of 18 is the square root of 9 times the square root of 2, because it did say to simplify. So I get 3 square root of 2. So the center is this, and the radius is 3 square root of 2. Okay, number 10. So number 10, you want to rewrite this circle that's in general form into standard form, and you want to use completing the square. So remember, to do that, you're going to group the x's together and group the y's together. The good thing is that the constant's already on the other side. So I get x squared plus 8x plus, so I'm going to add some number to this. Remember, so adding a number to this, you want to make this trinomial a perfect square trinomial. Do the same thing with the y, so y squared minus 10y plus some number here that will make this trinomial perfect square trinomial, and then that's going to equal negative 3. And so remember, you add something here, you got to add it here. You add something here, you have to add it there. So remember, the completing the square, you take the coefficient of x, which is 8, take half of that, and then squared. So 8 divided by 2 is 4. 4 squared is 16. So you add 16 here, add 16 here. Over here, take the coefficient of y, which is negative 10. Do the same thing, divide by 2, and then squared. Well, negative 10 divided by 2 is negative 5, and negative 5 squared is 25. So you can add 25 here, add 25 there. And so therefore, this perfect square trinomial factors as x plus 4 squared. This perfect square trinomial factors as y minus 5 squared equal, and when you add negative 3, 16, and 25, you get 38. So this equals 38. So your standard form is going to equal, and you just write this. So it'll be x plus 4 squared plus y minus 5 squared equals 38. All right, so that was number 10. Number 11, you want to solve this system, and Remember, you're told to write this as an ordered pair, and you're told to use substitution. The easy thing about this problem is that the second equation, the variable y is already by itself. So that's an easy one. So since y is already by itself, you're going to take this expression and you're going to substitute that into y here. And so you get 2x minus 3 times y, and y is 3x minus 7, and that's going to equal 7. And so notice you have this linear equation, so I'm going to distribute the negative 3. So I get 2x minus 9x. Negative 3 times the negative 7 is a positive 21 equals 7. Combine like terms, I get negative 7x plus 21 equals 7. Subtracting 21 from both sides, I get negative 7x equal a negative 14. 7 and negative 21 is a negative 14. Solving for x, I'm going to divide both sides by negative 7. Negative 7 divided by negative 7 is 1. And so you get x to be negative 14 divided by negative 7 is a positive 2. So I solve for x. So remember the ordered pair, right? So my solution, remember an ordered pair is a point, so you have to use that parentheses. So your x coordinate is 2. You just found the x coordinate. Now you have to solve for y. And to solve for y, it does not matter which of these equations you use. I would use this because y is already by itself. So in place of x, you're going to substitute 2, because that's what we just found x to be. So I get y equal 3 times 2 minus 7. So that's 6 minus 7, which is negative 1. All right, so there's your solution to number 11. So remember, always follow directions. And that brings us to number 12. So remember, the directions did not say use substitution. Directions said use addition, elimination. You must follow directions. So if you use substitution here, you're not going to get any points because you did not follow directions. Okay, so you want to use you want to use addition, elimination. And there are two approaches you could have taken. You could have eliminated the x's, or you could have eliminated the y's. Does not matter. So let's look at both approaches. So let's say that someone wanted to eliminate the x. All right, so that's going to be the work for here. So I'm going to go ahead and rewrite these two equations over. And so I get 5x minus 3y equal negative 1, 3x plus 2y equals 7. So if I want to eliminate the x, I got to make sure that these coefficients are opposites of each other. So the least common multiple of 5 and 3 is 15. But I want one of them to be negative. It does not matter which one is negative. I'm going to go ahead and just make the coefficient here negative. So if I want this number to be 15, I've got to multiply the left side by 3 and the right side by 3. And if I want this coefficient of x to be 15, I got to multiply the left side by 5 and the right side by 5. So what you do to the left, you do to the right. But remember, we said a while ago that they have to be opposite. So I'm going to go ahead and make this negative and this negative. Okay, so now what we get is this. Distributing the negative 3, I get negative 3 times 5x is a negative 15x. Negative 3 times the negative 3y is a positive 9y equal, and the negative 1 times the negative 3 is a positive 3. The second equation, 5 times 3x is 15x, 5 times 2y is 10y equal, and then 7 times 5 is 35. Now if I add those, notice the x terms add up to be 0, so here's the idea of eliminating the x. 9y and 10y is 19y equal, 3 and 35 is 38. Dividing both sides by 19, I get y to be 2. So once I find my y, the value of y, and so basically so far you just found your y coordinate of the ordered pair to be 2. So remember, that's your y. Now we got to solve for x. It does not matter which of those two equations you use. I'm going to go ahead and use the bottom one since every coefficient and constant is positive. It does not matter though. So I'm going to use 3x plus 2y equal 7. So in place of x, in place of y, I'm going to substitute 2. So I get 3x plus 2 times 2 equals 7. 3x plus 4 equals 7. Subtract 4. I get 3x equal 3. Divide both sides by 3. I get x to be 1. So there's your value for x. So x is 1. So there's the ordered pair. So that ordered pair will make this equation true and this equation true at the same time. And you can check, see that 1 and 2, x is 1, y is 2, 3 times 1 is 5, 3 times 2 is 6, 5 minus 6 is negative 1. 3 times 2 is 6, 2 times 2 is, 3 times 1 is 3, 2 times 2 is 4, 3 plus 4 is 7. Alright, now, someone else could have eliminated the y. So let's see what you would have done if you had done that. So I'm going to rewrite those two equations over. So 5x minus 3y equal negative 1. 3x plus 2y equal 7. Now if you want to eliminate the y, you got to find the least common multiple of these coefficients. The good thing about this one is that this is already negative, this is positive. So you don't have to multiply one of the values by negative here, because this is negative, this is positive. So if the least common multiple of 3 and 2 is 6, so I'm going to multiply the first equation. If I want 6 here, I got to multiply that by 2 times 2. If I want this to be 6, I got to multiply 2 by 3. So say times 3 times 3. And when I do that and distribute, I get 2 times 5x is 10x. 2 times the negative 3y is a negative 6y equal, and the negative 1 times 2 is a negative 2. 3 times 3x is 9x. 3 times 2y is 6y equal 7 times 3 is 21. Alright, adding those, 10x plus 9x is 19x, 6y and negative 6y is 0 equal negative 2 and 21 is 19. Divide both sides by 19. I get x to be 1, which is what we had. Now we got to solve for y. Solve for y. So again, it does not matter which equation you use. I'm going to go ahead and use the top one since I used the bottom one for this one. So if you use the top equation, 5x minus 2y equal negative 1. Of course, it would have been easier to use the second equation because all these numbers are positive. Alright, in place of x, I'm going to substitute 1. So I get 5 times 1 minus 2y equal negative 1. 5 times 1 is 5, so 5 minus 2y equal negative 1. Subtracting 5 from both sides, 5 minus 5 is 0. So I get negative 2y. Be careful, that's negative 2y equal a negative 1 and a negative 5 is a negative 6. Dividing both sides by, I made a mistake. Let me see what I made, where that mistake is. Let's see, because I need this to be 2, right? Alright, so let's see where a mistake is. So that's x is 1. Oh, well, let's see. So 5 times 1 is 5. Alright, and then minus, oh, I'm sorry, here's my mistake. So that's a 3, right? So I got, yeah, that's a 3 right here. So I made that to be a 2. So I knew I had a mistake because when you divide by negative 2, you get a 3. And that's not what we have here. So be careful. So that's a 3 here. That's a 3. And that's a 3. Alright, so now it'll work. Dividing both sides by negative 3, I get y to be 2. And that's what we had. Alright. Okay, so that was number 12. Okay, let's look at number 13. Okay, so number 13, we have this. Okay, so in this problem, you wanted to determine whether each relation represents a function or not. And the direction said write either function or not a function for each. So let's look at the part A. So let's think about part A. So in part A, since that's a finite set of ordered pairs, I'm going to use the idea that mapping. So remember, a function for each x coordinate, there has to be exactly one y coordinate. So when I look at this in terms of a mapping, this is your x, this is your y. When x is 2, I get a y value of negative 3. So for each x, that must be only one y. So far we're okay. When x is 7, I get a y value of 2. So that's good. When x is 6, I get a y value of 3. That's good. When x is negative 5, remember only listed once. When x is negative 5, I get a y value of negative 3. But notice that each of these x coordinates, there's only one y coordinate attached to it. It's okay for two different x coordinates to have the same y value. or the two x values have the same y value. All right, so that's a function. So you write the word function there. That's what the direction said. Now, if we look at part B, we have, if you look at this in terms of mapping again, we have when x is 8, y is -1. So 8 gets paired with -1. When x is 0, y is -4. When x is 5, y is 7. When x is -1, y is 10, right? So notice that for each of those x values, there's only one value attached with it. So let me make sure. Oh, I forgot the other one. I'm sorry. Forgot this one. So when x is 8, now I already have that 8, right? So listen again. When x is 8, I get a y value of 0. So I forgot about this one. So notice that this is not a function because when x is 8, there are two different y values. The definition of a function says for each x coordinate, there's got to be only one y coordinate. Here you have 2 for x equal 8. So this is right here, and this right here are the ones that makes this not a function. So that's not a function. All right, now when we look at part C, I want you to recognize that this is a line, right? That's a line. That's a linear equation. So right away, if you knew that was a linear equation, that's not vertical, then it's a function. And so if you get y by itself, you get y equals -2x plus 8, right? -2x plus 8. And you'll notice that and you could use a t-table. So there are multiple ways to do this. If you use a t-table, when x is 0, using the definition of function for each x coordinate, it's got to be one y coordinate. When x is 0, notice -2 times 0, 0. 0 plus 8 is 8. When x is 1, -2 times 1 is -2. -2 plus 8 is 6. When x is, let's say, -1, -2 times -1 is a positive 2. 2 plus 8 is 10. When x is 2, -2 times 2 is -4. -4 plus 8 is a positive 4. When x is -2, -2 times -2 is a positive 4. 4 plus 8 is 12. And you can continue, but what you notice is that for each of those x coordinates, there is just one y value attached with it. So that's a function. Now the other approach is to look at this in terms of a graph, which you all know how to graph this. So remember the slope here is -2, right? Slope is -2. I'm going to write this as -2/1, and the y-intercept is 8. So the y-intercept, so let's say that's where the graph crosses the y-axis. The slope is rise over run. So I go down 2 to the right 1, and then notice if I graph this, it passes the vertical line test. So that's a function. So there are two ways you could have looked at this problem and noticed that this is linear and that's a function. Same thing here. So when you look at this one in part D, you have y equal absolute value of x plus 3. So the best approach to use there, and what most students use, is this t-table. If you notice that the absolute value, the graph of an absolute value is at v, then you can use a vertical line test and say it's a function, because notice the graph of this, remember the parent function, the absolute value of x. So here's the absolute value of x, right? Oops, y equal absolute value of x. And then that 3, you just shifted up 3, right? So there's y equal absolute value of x plus 3, and those are vertical line tests. So it passes the vertical line test. So that's a function. But many students revert to that t-table to help them. So when x is 0, the absolute value of 0 is 0. 0 plus 3 is 3. When x is 1, the absolute value of 1 is 1. 1 plus 3 is 4. When x is -1, and be careful, you get the absolute value of -1, right? Plus 3, and the absolute value of -1 is a positive 1. 1 plus 3 is 4. So remember, it doesn't matter that you have the same y value for two different x values. It does not matter. Remember, the definition of function says for each x, there's only one y. And you can continue on, and you'll notice that accept that this is a function. For each of these x values, you will have exactly one y value. So the absolute value of 2 is 2, 2 plus 3 is 5. Okay, so that one's a function. All right, so that was number 13. Okay, so let's look at number 14. All right, so you're given these two functions. This is function f, this is function g, and you want to find these parts here. It says no work is needed for part A and B, but work is needed for part C. So let's look at part A. So here's part A. And in part A, you want to find g of 3. So make sure you go to the correct functions. So g of x is this quadratic function here. So where we see the variable x, you're going to substitute 3. So I get 3 times 3 squared minus 2 times 3 minus 3. 3 squared is 9. 9 times 3 is 27. 2 times 3 is 6. That's minus 6 minus 3. 27 minus 6 is 21. And 21 subtract 3 is, was that 18? So that one is 18, right? All right. So in part B, you want to find g of negative x. So here's part B. You want to find g of negative x. So in place of x, again, you go back to the g function. So in place of x, you're going to substitute negative x. I get 3 times negative x squared. All right. Minus 2 times negative x minus 3. But remember, negative x squared, let me go put that here. Negative x squared means negative x times itself. Well, negative x times negative x, a positive x squared. So this becomes, g of negative x becomes 3x squared. So this right here is the same as this. A negative 2 times negative x is a positive 2x minus 3, and there's your answer for that part. So we get 3x squared plus 2x minus 3. All right, and then part C, you want to find f of 3x minus 1. Now be careful, this time you got to go to your function f, which is this. So here's my function f. It's 2x minus 5. So in place of x, you're going to substitute 3x minus 1. So I get 2 times 3x minus 1 minus 5. Distributing the 2, I get 6x minus 2 minus 5. A negative 2 and a negative 5 combining like terms is 6x minus 7. So that 6x minus 7 is f of 3x minus 1. So 6x minus 7. All right. Now, for some reason, some students want to go ahead and set that equal to 0 and solve for x. That's not what you're asked to do here. You're just asked to find the expression for f of 3x minus 1. So you got to be careful, because you're not solving an equation there. You're finding the function at 3x minus 1. All right, so that was 14. Okay, so let's look at 16. So actually 15. In 15, you're given this finite set of ordered pairs. And so there's your function f. So f is a finite set of ordered pairs, and that's a function. For each x value, there's only one y value. You want to find f of 5. So remember, f of 5 means what is the y value when x is 5? That's what that means. So remember, what is the y value when x is 5? Well, when x is 5, that's here, right? When x is 5, my y value is negative 2. That's all you write. In part B, so let's go to part B. You want to find 3 times f of 7. So first of all, you got to look at this f of 7. So what's the y value when x is 7? Same thing like part A. Well, when x is 7, that's this, my y value is 4. So this becomes 3 times 4, which is 12. So that goes here. In part C, you want to find f of 0 plus f of 4, right? Well, f of 0 means what is the y value when x is 4? I'm sorry, 0. When x is 0. Well, that's this one. When x is 0, y is negative 3. So this is negative 3. Then you're going to add that, though, to f of 4. Well, what's the y value when x is 4? Well, when x is 4, my y value is negative 5. So negative 3 plus negative 5 is negative 8. So that goes here. In part D, you want to find f of negative 2 plus 4 times f of 5. Well, f of negative 2, what is a y value when x is negative 2? Well, when x is negative 2, my y value is 3. Plus 4 times f of 5. What is a y value when x is 5? Well, when x is 5, my y value is negative 2. So this becomes 3 plus 4 times negative 2 is a negative 8. 3 plus negative 8 is negative 5. So negative 5 goes here. Okay? All right, now in number 16, you want to find the domain and range of this function. Notice that this is a segment with this endpoint being closed and this endpoint being open. So it helps if you use a ruler, and I don't have a sharp ruler, I'm going to have to use this one, but it helps if you have a ruler to help you with this. So remember, the domain is a set of x coordinates. The range is the set of y coordinates, the y values. So in finding the domain, notice that this endpoint's here, right? And it's closed, so hence that idea of that bracket. We use a bracket here, and open we use parentheses. So notice that this x coordinate here, set of x coordinates, you go from left to right along the x-axis. Since I'm looking at domain, this x coordinate here is a negative 7. So you're going to say bracket negative 7, comma, all the way, and then it stops here, right? There's no arrow, so this is where it stops, and that x coordinate is 2, but since that's an open circle, we're going to use parentheses. Then you do the same thing with the range. So with the range, you go along the y-axis, but remember the interval notation is always from smallest to largest. That's why we go from bottom up. So here, that's where the point starts here, but it's open. This y value is negative 3. So it'll be parentheses negative 3, comma, and then it stops here, and that y value is 6. But that's a closed circle, so it's 6 with a bracket. All right, and that was number 16. And then finally, number 17. That one was an easy one. You want to remember, you know this is a linear equation. We just had a linear equation a while ago, and you want to determine which one of these best represents that graph. The way to do this is to actually get y by itself. So we have 3x plus 2y equal 8. So basically you're writing this in slope-intercept form, right? So slope-intercept form, which is y equals mx plus b. That's the best way to do that. So if I get y by itself, I get 2y equal negative 3x plus 8, dividing both sides by 2. I get y equals negative 3 halves x, right? And then 8 divided by 2 is 4. So notice that my y-intercept is 4. So right away, I know it's not going to be this one, right? Because that's negative 4, and it's not going to be this one either because that's negative 4. That's where the graph crosses the y-axis. So my answer is either going to be A or B. Well, let's look at the slope. So my y-intercept is 4, right? And so since the slope is negative 3 halves, rise over run, that means I'm going to go down 3 and then to the right 2. So from this y-intercept, let me go ahead and do that here. 1, 2, 3, 4. From this y-intercept, I'm going to go down 3, 1, 2, 3, and then to the right 2, and this is your graph. So the one that best represents that is B, right? Because look, from here you went down 3, right? 1, 2, 3, and then to the right 2. Here, it looks like you went down 2 and then to the right 3. 1, 2, 1, 2, 3. So remember, slope is rise over run. So this is the one right here. So that's the answer. Okay. All right. So that was the key to test 1. Remember, that covered topics 1 through 12. So that's the topics 1 through 12. All right. So that's the key to test number 1.